So, PME's finished its first decade. Where do we go from here? In May 2019, the gift from the Pritzker family supported the transformation of the Institute for Molecular Engineering into the Pritzker School of Molecular Engineering, the first school in the nation dedicated to engineering systems from the atomic and molecular levels up. Over 10 years of intensive growth, PME has largely achieved and in some respects surpassed the original plan for the establishment of the IME. But with a new school comes a new strategic plan. The next 10 years will be about the scale of our existing activities, investment in strategically chosen new opportunities, broadening educational offerings, and acceleration of commercialization activities. PME started with the mission to affect profoundly the future of engineering and applied science research and education, and ultimately to benefit humanity. Our focus on a few singular transformative topics in engineering science has enabled us to compete with the very best traditional engineering programs in those areas. We believe that this style of faculty building will continue to yield good results. Today, along with PME's relative youth, come other challenges to the full achievement and realization of our capabilities. The first challenge I've already mentioned is scale. As strong and distinctive as the themes are at this stage of development, they're few in number and relatively lightly populated with faculty. Increasing scale is important to provide a better spectrum of opportunities to our students, to be able to attract more of the very best students, to be able to capture attention and resources from a broader spectrum of audiences and sources, and foremost, to extend the successful PME operational model to new important areas of engineering. A second challenge is about making choices. As PME pursues its demonstrably effective faculty building style around focused themes, in order to seize new opportunities and capacity, it must also ensure faculty diversity to achieve real distinction and influence, maintain an internal unity and common vision so that the themes do not devolve into, for example, de facto departments, and seek uncommon synergies resulting from its unique organization. Opportunities abound, and PME must make the right choices. The third challenge is about integration, internal and external, to PME at the University of Chicago. Internally, the optimum balance has to be found between connectivity among and sharp distinctiveness in the themes that we have. Bringing out uncommon synergies among the themes is the objective, not filling in gaps between them. The full value of PME for the University of Chicago can't be achieved at UChicago on a decade-long timescale by PME alone. Campus-wide integration and long-lasting partnerships internally and externally will bolster the deepening of knowledge in these fields and broaden the reach to adjacent complementary synergistic domains. PME will simultaneously become better connected with various departments and programs on campus through synergistic collaborations and joint hiring. Cooperation and integration with programs at Argonne is an important part of this goal. We have enumerated a set of definite goals for the next decade. I'm not going to read or explain these in detail, but hit some highlights of our objectives. Among the 6 overarching goals PME has for the next decade, first and foremost is enhancing and enlarging the current themes and developing additional themes and cross-cutting areas. PME must continue to grow its existing platforms and strengthening its emerging leadership position in immunoengineering, quantum engineering, and materials for sustainability. While PME has recognized international leadership in each of these areas, there's more to be done to achieve the range and mass of talent required to have field-defining and internationally competitive impact. A planning process to inform the next phase of hiring in PME has been underway all summer long, involving all the PME faculty, and a full implementation plan will be completed this fall. Many new themes are under consideration, though none have been decided yet, but here are a few examples. One idea is biological design. The opportunity is to develop a systematic approach to discover how evolution as a process has been driving structure and function. A PME theme in biological design could use artificial intelligence and data-driven evolution-derived approaches to proteins whose properties exceed any known natural protein. This goal differs from the Nobel Prize-winning approach that we heard this morning of directed evolution developed by Francis Arnold at Caltech, which literally evolves new protein function by empirical rounds of screening. Here, we want to learn more and employ more the tools that natural evolution has used. What I've illustrated here is a picture including two of our faculty members, Rama Ranganathan and Andy Ferguson, who've started a very interesting company called Evozyne in this direction. But there's many other things we could do in the bio design area as well, and we're thinking hard about them. Another area is space technologies. A PME thematic area in space technology would concentrate on research performed from space, like astronomy or climate science or geology, space systems like propulsion, satellites, communications, electronics, and so on, augmented by ground-based space research. A space technology theme could also stimulate or synergize with work in existing themes, some more obvious than others. Quantum communication satellites, imaging technologies, batteries and power systems, soft robotics, additive manufacturing, and so on. We could capitalize on the fact that it is now possible to design and launch a cube satellite in less than 2 years for around $100,000. In addition to strengthening existing themes and building one or two more new ones, the future growth of PME must address the need for deeper team of expertise in certain enabling and cross-cutting capabilities that will reinforce all of the themes that we have. For example, theory, computation, machine learning, material synthesis, and instrumentation. So we're thinking about new themes and cross-cutting areas, and as has become obvious in some of the discussions even just now, who we can get to lead these activities is going to be one of the most important criteria of exactly what we do. In education, PME has involved 3 strong tracks at both the undergraduate and graduate level. Perhaps the most exciting innovation is the set of minor topics created by Paul Neely to give both PME and non-PME students in-depth knowledge in specific areas. We think in this way we are really contributing new material and enrich the curricular offerings of the University of Chicago. And a thing that Paul has generated is the ability for PME students to take these minors, if you will, to have a deep knowledge in one specific area of molecular engineering on top of their more general basic engineering background. And finally, a new building is essential to realizing any of these goals. As you can see from this list, while we have our headquarters in the Eckert Research Center, we are spread over 10 different buildings and are short on capacity and collegial proximity. So we're very excited and appreciative that the Board of Trustees has approved a plan for a new building to be located just north of our current location, or at least our headquarters location in the Eckert Center. That will not only help us expand and consolidate, but will also give rise to the possibility of unique co-localization in Hyde Park with UIUC, possibly with Argonne, with industrial partners, and many other opportunities. So that's the view now on our thinking about the next decade. It's still very much a work in progress. We're not at all complacent. Just as in the first decade, in the second decade, PME will be prepared and opportunistic. We aim to make the second decade at least as exciting and as successful as the first. So thank you very much. That's how things look from here for the next 10 years.